Welcome to qnawire.
Hi, so in this case we have two different questions. The first one is which would you expect to have a higher molar heat of vaporization? First of all, we have water, which has a boiling point of 100 degrees Celsius, and we have methanol with a boiling point of 78.4 degrees Celsius. So we would expect water to have a higher one because since the boiling point is higher, that means that you require more energy in order to achieve the change of phase. So that is the macroscopic explanation in terms of energies. The boiling point is higher, you need more energy in order to make the transition from H2O liquid into H2O gas. And in a microscopic sense, what is happening is that the molecule of water can create hydrogen bonds with other molecules of water. And even though in methanol, you can have a similar effect, the issue is that since we have a bulky substituent, we have the ethyl group over here, these bonds are not going to be as strong as they are in water. Also, for example, here the waters can generate more and more layers of hydrogen bonds, while in methanol, what is happening is that this steric effect is going to make the hydrogen bond weaker. So that is the microscopic explanation, and with that would be all for part one. Now for the second part, we're asked what is what equation defines delta H in general terms, and how is this expressed when the system involves a chemical reaction? And in general, why are chemists and biologists more interested in values of delta H than delta E? So for the first part, delta H is defined directly as delta U plus P delta B. This comes from the definition of H that tells us that H is equal to U plus PV. In this case, this is true only when the pressure is constant. In the most general case, what is going to happen is that delta H will be equal to delta U plus P delta B plus B delta P. Where does this come from? It comes from the differentiation of H from its definition that tells us that this differential is equal to du plus b differential of p plus b differential plus p differential of b. And integrating, you can arrive to this relationship, which is the most general case that you can have. Now, how do we express this when we have chemical reactions? Well, in general, for chemical reactions, what we are going to have is a process that starts from reactants and goes towards products. So the way that we express delta H in general is going to be the sum of the enthalpies of formation of the products multiplied by the stoichiometric coefficient, I'm going to call it say for products, minus the sum of the enthalpies of formation of the reactants. And same thing, multiplied by the stoichiometric coefficients of the reactants that we have. So now, why are chemists and biologists more interested in values of delta H rather than values of delta E? Well, because we can draw a direct relationship in between the enthalpy for a reaction and the bonds that are being broken and the bonds that are being generated. In general, the enthalpy of a reaction, we can look at it as the sum of the bonds that are being broken minus the sum of the bonds that are being formed. And that would be all. Thank you very much and have a good one.